Welcome everyone. I am building a contraption. Well, what exactly is this? I have two motors connected together with a 3D printed coupler, and I have some other stuff going on this end. And exactly what is this? Well, it's a motor dyno. I'm wanting to measure the horsepower of motors, electric motors. This could probably be used with like small two-stroke motors, like weed eater motors or something, to figure out how much power I'm getting out of them. And I mean, it's a simple build, but it's pretty complicated, and I will get into some of them. So, exactly what do I have going on here? This right here is is a 1 horsepower motor, and I'm calling this my calibration motor, since I know this is a 1 horse motor. And then this here is a 2 horse motor. This is actually a 3-phase motor out of a large treadmill, but this motor is not connected to nothing. It's just freewheeling. There's no power to it, no nothing. Pretty much the rotor inside of this is just acting as a flywheel. So all it is a spinning load on this motor. Now this being my flywheel, to say, it's pretty much exactly what it's acting as. It's just a flywheel. For reading how many RPMs this is spinning, I have another little 3D printed wheel here, and it has a little magnet in the end of it here, and then I have this little board that I've made with some connectors and a Hall effect sensor. A Hall effect sensor just pretty much, it picks up a magnetic field, so every time that magnet passes by that Hall effect sensor, it sends a pulse to an Arduino that I have hooked up to this, which then interfaces into my computer. My Arduino I have it housed in this little steel casing here. This was an old power supply that I took apart for the casing, and I have the Arduino inside of it, and then also running from the Hall effect sensor to the Arduino. This is a 3 conductor shielded wire, and the reason for the metal case, which is grounded to the Arduino in this shielded wire, is just for interference problems. When I first tried using this setup, I had tons of just interference in the things, messing with signals to the computer and this and that. It was a total mess, and it was just not working for absolute nothing. But doing this, putting a case around the Arduino and running shielded wire, fixed all my problems. Now looking here at my laptop screen, this is a program called Simpledyno, and I will put a link to it down in the description. It's a program that's not supported anymore, but it works. It's got a few little things I'm not big on, but I'm slowly figuring it out, and I mean, it works. So looking at it right now, we have a gauge for RPMs. This is the same gauge here, just giving you a number, your RPMs. This is your maximum RPMs. And then this is RPMs and the time. Now how this dyno works is it measures how much inertia the flywheel has. So with the amount of inertia a flywheel stores, that's how much energy it stores. It takes so much energy for that flywheel to change speed. So this program uses them calculations to figure out how much power and torque and stuff the motor's putting out. It's actually pretty cool, and all it runs off of is the RPM signal, and then you put in your weight and measurements and all that to calculate the moment of inertia that your flywheel has. So if I come over here and spin it by hand, you'll see the RPMs there changed, and you can see the graph on the right hand side change also. Then it gives you how many maximum RPMs it had. This is just spinning it by hand. So now we'll do a quick little run of the motor and see what happens. Now the motor just has to run just long enough to get up to full speed, and then I'll shut it off. So I'll go down here and I'll click on power run. And we're ready to start, and I'll plug the motor in. See, we had a maximum RPMs of 3,594, which is pretty well on. It's a little higher than what the motor's rated for, but I mean, that's no real big surprise. This graph tells you is pretty much data graphs. So let's go to analysis. And here we go. Now, right now, as I have this tuned, and I've still got some more tuning to do on this, it's saying I'm getting 0.78 horsepower out of this 1 horsepower motor. I mean, that could be fairly accurate. I mean, it's an old motor. The bearings on it in it are not the best, if you can tell by the sound of it when I run it. And I mean, I could be getting close, but I'm still going to kind of use this as a standard, and I'm going to play with this a little more. This is all a learning process, and I can set this graph up, other settings in this graph, to do many things. Go to the link for the Simpledyno and download it. There is a 40-page instruction PDF that you get with the download that it kind of help you understand and tells you how to set some of this up. I'm still in process of that and learning this stuff. So let's do another run just for the heck of it. There we go. By this graph right up here, it's really hard to see. Let's go to the analysis screen, and 0.775 as I've got the software tuned right now. So I'm getting good consistent numbers out of this. So my signals from everything is working really great. So that's pretty much the rough rundown of what I've got going on here. Trying to make me a motor dyno with just a free spinning motor. This acts just as a flywheel. The rotor in this weighed 9 pounds and something, so I was kind of worried about even this 1 horse motor to really be able to spin this, but there's no issues whatsoever with it. So I'm wondering about even smaller motors, like a 1/3 horsepower, 1/4 horsepower motors like that, if it will spin this no problem. Another thing I could do with this is hook up small 2-stroke motors to it like this. That way I could play around with different exhausts, different carburetors, just see what kind of power difference that makes. All I'd have to do is make a coupler for it and mount the motor and have it coupled up to the flywheel, kind of like so, to test 2-stroke motors. I think that would be kind of a neat little something to play with and a little learning experience pretty much. But overall, what's my big plan for this thing? Well, I have a little video series. If you have not saw it, go check them out. And that's taking a alternator and converting it into a motor. I call it a brushless motor, but honestly it's more kind of a hybrid motor. It can be made brushless with a little more engineering work, but it's kind of a hybrid outfit with an alternator. And here is my alternator in question that I've done. I've turned this into a motor, and in my next video I'm going to get into hooking this up to this and just seeing if this will even spin this motor. That way I can measure how much power I can get out of this. And I'm just really curious, what kind of power numbers can I get out of this alternator running on 48 volts. And just, I don't know, it's a thing I've been wanting to do for a very long time, since I even started that whole series of videos on how to turn this into a motor. And I will throw a link also below to my best video, what I call the easy way of doing it, and we will get into that. So in the next video, look forward to that we will see what this will put out on this contraption. I'll be taking this motor off and connecting the alternator up to my rotor flywheel here and seeing what kind of numbers we get on the computer. I'd like to say thanks for watching, and until next time, I'll see you later.